This playlist is part of the Predicting Products of Chemical Reactions, and this is our third video, which is on synthesis reactions. Now we're going to need the guideline for predicting products here. On the left, you're going to see a yellow box. Those are the reactions that we're going to focus on today. And just as before, we should know all of the ion charges. You have to be very comfortable with the positive charges and the negative charges. Here's our first example. Let's take a look at the top first to see what synthesis reactions generally look like. So in a synthesis reaction, we basically have two things that are by themselves and they come together. Isn't that just neat? Okay, let's take a look at the left now. On the left, you can see that there are generally three types of synthesis reactions. The first type is called the formation of a binary compound, where two lone elements come together, and then they form a compound, which is two elements bonded together. The second type of synthesis reaction is called a metal oxide and water reaction, and it's basically in a name. You need a metal oxide and water. The third type of synthesis reaction is called a non-metal oxide and water reaction. And just like in the name, you need a non-metal oxide and water. Let's look at the bottom now. Here's our first example. We have potassium metal reacting with chlorine gas. Now, both of these are lone elements. We have just potassium and chlorine. So this must be a formation of a binary compound. And in a formation of a binary compound, you just stick those elements together. So potassium and chlorine, that's what we want to write together. Okay, now I just wrote potassium and chlorine, but I want to make sure I check to see if this compound is written correctly. And we can check to see the charges. Do they cancel out? We should know that potassium is a +1 charge. We should also know that chlorine is a -1 charge. You only need one of each ion, so KCl is correct the way it's written. It's not supposed to be KCl2. Okay, so we look at the charges to see if it's correctly written. I'm going to go ahead and write the names of these compounds as I'm doing them. You don't really have to do this, but I do encourage the practice. All right, let's move on to our second example. Here we have sodium oxide reacting with water. Okay, this is one of the synthesis reactions that contains water, but which one is it? Well, is sodium oxide a metal oxide or a non-metal oxide? Well, since sodium is a metal element, this must be a metal oxide and water reaction. Okay, so for a metal oxide and water reaction, the product should be a metal hydroxide. So we're going to include our metal, which is sodium in this case, and we're going to include hydroxide, and hydroxide is OH. But we want to check to see if this is correctly written, and we can check to see if it's correctly written by looking at the charges of this ionic compound. Okay, so the charge of sodium should be Na +1. The charge of hydroxide should be OH -1. All right, since it's +1 and -1, you only need one of each ion. So the way that we have it written, NaOH, it's correct. Okay, we have to do this check to see if it is correctly written. And now we have here carbon dioxide reacting with water. Okay, so which type of synthesis reaction is this? Well, it contains water, but carbon dioxide, is that a metal oxide or a non-metal oxide? So, well, since carbon is a non-metal, this must be a non-metal oxide and water reaction. So we're going to be following this reaction right here. And if we do follow it, you're going to notice, oh, what do we have here? It's an H with a non-metal oxide. Okay, so this can be a little bit confusing. We're going to write H, but what is our non-metal oxide? This is where you're actually going to need to look at your common ion table. and see which nonmetal oxide most closely resembles CO2. If you look at your common ion table, you're going to see that there is a carbonate ion, CO3. That's going to be the closest matching ion. Okay. Okay. And now we're going to go ahead and check to see if this is correctly written. So we're going to write the charges and see if it's balanced. All right, if you take a look at the charges, you're going to notice, okay, there's only one positive charge, but there's two negative charges. So in fact, we need two hydrogens, okay? We need two hydrogens, so we're going to go ahead and fix this by writing a subscript 2, so it says H2CO3. Okay, this one's a little bit challenging because you do need to refer to your common ion table to figure out what's the closest resembling nonmetal oxide is. Okay, once you do that, you proceed everything the same way. On the next slide, you're going to have, I believe, 4 examples to try. I do want you to pause the video first and try it on a piece of scratch paper before you take a look at the answers. All right, so again, try this on your own first before you look at the answers. And here are the answers. Now, if you didn't get the answer the way that I've written it, then you can go ahead and take a look at the ions to see where you could have improved your answer. And here are the ion charges. So take a look at it one more time. And after this, you can go ahead and try a few more practice problems, and then I can give you feedback for it.